Okay, so for this video, we are going to discuss the paper 3 pure maths 3 paper for May June 2021. Okay, so let's have a look for the first question. Okay, so for the first question, they want us to expand this bracket with power 2 over 3 in ascending powers of x up to and including the terms in x power 3. Simplify the coefficients. Right, so for this question, generally it is binomial expansion. So for binomial expansion, in A2 level, we are going to use this formula. Right, and when you want to apply this formula, the very first thing is you have to ensure that the first term in the bracket should be a 1. That only you can apply the formula here. Okay, so according to this formula, the x in our question will be the whole second term, okay, in the bracket, which is 3x. Alright, so that means later in the formula here, wherever we are having the x here, we have to replace it with 3x. And for this one, the power will be the power n. Okay, so n is equals to 2 over 3, and the x will be the 3x. Right, so we'll start substituting all the values inside the formula. Right, so to expand it, we are having 1 plus 3x power 2 over 3. Okay, so you can see that the first term is already started with 1, so we are not going to do any adjustment. We can straight away apply the formula. Right, so we can straight away apply this one. Okay, so the first term will be 1, so which is a 1. And the second term is nx, so the n here will be the 2 over 3. And the x in our question here should be the second term, which is 3x. Alright, and plus the next one. So the next one will be n multiplied with n minus 1. So our n is 2 over 3. And n minus 1, I will get negative 1 over 3. Okay, and divided by 2 factorial, x power 2. So x power 2 means that you're having 3x and you square the whole 3x. Next, we go to the next term. So the next term will be n, again, which is 2 over 3. N minus 1 will be negative 1 over 3. And n minus 2. So n minus 2, you will get negative 4 over 3. Right, then divided by 3 factorial, multiply with x power 3. So x power 3, our x here will be 3x, and then you power the 3 for the whole 3x. And we will stop here because you can see that if I expand the power 3 into the x, right, I already have the x power 3 in my expansion. So I will stop here at this term. Alright, okay, so very easily, you just try to press calculator and simplify all the values here. Right, so the first term will be a 1, the second term will be 2x, okay, the third term will be negative x squared, and also the fourth term will be 4 over 3x power 3. And this is my final answer. Alright, so this is how we answer the question number 1. Okay, so question number 2. Alright, so they want us to solve this equation and then give our answer to 3 decimal places. Okay, so maybe we can start now. I'm having 4 power x, then equals to 3 plus 4 power negative x. Alright, so if I rephrase it again, you will see something like this. The 4 power negative x, I can rewrite it become 1 over 4 power x. And maybe from here, I would like to replace the 4 power x as y so that later you can see it in a clearer way. Right, so you are let y equals to 4 power x, and therefore your equation becomes something like this. Then I want to make the denominator disappear for the y. Okay, so I multiply the whole equation with y. So I'm having something like this. And when I move all the terms to left hand side, you can see very clearly that I actually get a quadratic equation. Okay, so to solve the quadratic equation, if you try or attempt to factorize this one, you will realize that it's not able to factorize it. So you will apply the quadratic formula, okay, to solve for the y. So I'm having b squared minus 4ac divided by 2a. So eventually your y should be having two values here. So you're having 3 plus minus square root 13 divided by 2. Okay, so our original question here is actually in terms of x, right? 4 power x. Therefore, we need to separate out because y you are having two values, all right, and we want to try to get the solution or the value for x. Therefore, I will solve it by substituting back 4 power x, okay, into the y. So 4 power x equals to 3 plus square root 13 divided by 2. Another value will be 4 power x, then 3 minus square root 13 divided by 2. Okay, so if you try to press calculator, right, this is a negative value. And if you want to take ln or log for the negative value, you'll get a math error. So for this part, you will see that you actually cannot get a solution. So we ignore this part. Okay, right. Then we will continue for this. Right, so to get the x, you can take log both sides or ln both sides. It depends on your preference or your own preference. Alright, so to get the value of x, it will be very simple, where you just move the log 4 to the other side. So it will become divided by log 4. Okay, so if you didn't do any careless mistake, the answer for the x should be equals to 862 into 3 significant figure. Right, so this is the answer for question number 2. We come to question number 3. Question number 3, they are talking about the parametric equations. And they give you two equations here, two parametric equations here, x in terms of t and also y in terms of t, where you need to be aware that t is actually taking the value greater than negative 2. Okay, so maybe you should be aware of this. Okay, right, so for part A, they want you to express dy over dx in terms of t, simplifying your answer. Okay, so of course, when you want to get dy dx in parametric equations, you need to differentiate the two parametric equations separately first, right? So I'm having x equals to t plus ln t plus 2. So for this parametric equation, I'm going to find dx dt, dx over dt. Okay, so differentiate the t. The first term t here, you get a 1, which is a constant, then plus. When you want to differentiate ln t plus 2, you'll get t plus 2. Then you differentiate the t plus 2 itself in the bracket, you get a 1. So you're having 1 over t plus 2. Okay, so because I know that later I have to apply chain rule, right, to get the dy dx. Therefore, I think it will be better if I can try to change my answer into a single fraction. So if I want to change it become a single fraction, right, so I'm having t plus 2 plus 1, and therefore you're having t plus 3 over t plus 2. Then now we do the differentiation for the other parametric equation, y in terms of t. Okay, so this is my original equation here, y in terms of t, and you realize that for this part, you are having a product of two different functions. So I'm having the first function is t minus 1, the second function is e power negative 2t. Therefore, to get the dy over dt, you need to apply the product rule. Okay, so you can apply the product rule if you want. Okay, so product rule means that you differentiate the first bracket, you get a 1, then copy the second bracket or copy the second function, so which is e negative 2t. Then plus, you do the other way around. Now you copy the first function or first bracket, then you differentiate the second bracket. So differentiate e negative 2t, you will get negative 2 e power negative 2t. And again, because I want to simplify later, right? Okay, to get I want to apply the chain rule later to get the dy dx. So again, I will think that if I can factorize it into products or functions, will be easier for me to do the simplification later. All right, so I will factorize out the e negative 2t. The first term here left a 1. Okay, and for the second term here, what will I have is I will have negative 2t plus 2. And end up, I will have e negative 2t, then 3 minus 2t. Okay, so this is my dy dt. Okay, so to get the dy dx, I need to apply the chain rule now. Okay, so I will write out the dy dx here. So to get the dy dx is actually dy over dt multiply with dt over dx. Okay, so dy over dt will be 3 minus 2d, then e power 2d multiply with dt over dx. So you're having t plus 2, then t plus 3. Okay, so if you want to rewrite in a better way, then you can just rewrite it like this. So 3 minus 2t and then t plus 2 divided by e 2t bracket t plus 3. Okay, so this is what we have for dy dx. Okay, so first part of this question is something like this. Then now we continue to the second part, part B. Okay, so for part B, they are asking us to find the exact. So maybe you can highlight the word exact. So exact means that your final answer cannot be in um, the shortened decimal number. Okay, it should be in fraction form or pi form or with cert and etc. All right, so they want to have the exact value for y coordinate, okay, of the stationary point of the curve. All right, so when you see the word stationary point, it means it can be either maximum, minimum, or inflection point where the dy dx is equals to 0. Okay, so once you see this word, you know that you should let dy dx equals to 0 to solve it. Okay, so from first part, we are having the dy dx already here. Okay, so I will straight away let the dy dx. Okay, so I straight away let dy dx will be equals to 0. Okay, and after that, I will get two brackets on top. Okay, 3 minus 2t equals to 0, and also t plus 2 equals to 0. Therefore, I'm having the value for t, which is equals to 3 over 2, and also t equals to negative 2. And I will ignore this value for t equals to negative 2. Okay, so why I actually ignore this value? Okay, so again, I think I emphasized just now, right? If you have a look for the domain defined in the question for the t, it should be t greater than negative 2, which doesn't include the value of negative 2. Therefore, here when I get t equals to negative 2, I should ignore this value. Okay, so I'll continue from this part. When t equals to 3 over 2, I want to get the coordinate for y. So I will substitute into the y formula. So the y formula will be t minus 1. So t minus 1 multiply with e negative 2t. So when you have e negative 2t, you have, after you simplify it, you have e power negative 3. Okay, then again, you further simplify it, and eventually you will have 1 over 2e power 3, or you can keep your answer as 1 over 2, then e power negative 3. Both answers are accepted, but you have to keep it like this. Keep your answer like this in this form so that it remains as the exact y coordinate. Question number 4. They want us to express the function given in partial fractions. Okay, so if you look at the denominator, all right, it belongs to linear factors, okay, and also it is already in proper fraction form. As you can see here, okay, this one, the highest degree, the highest power for x is 1, so you're having degree 1, and for the denominator you're having degree 2, because when you expand the brackets you're having x power 2. Okay, so it is belongs to proper fraction already lah. So we can straight away find out, okay, the partial fractions for this function. Okay, so original function will look something like this. Okay, then I know that because both bracket here at the denominator are linear factors, so I'm having a over 1 plus 2x, then b over 4 minus x. Okay, then I multiply the whole equation with the original denominator for the function. Therefore, I will get the equation without the denominator anymore. Alright, then for the first bracket here, 4 minus x, I'm trying to make the 4 minus x become 0. So I will let x equals to 4. Okay, when I let x equals to 4, the value for this part, I will get negative 9. 4 minus 4 equals to 0, therefore the a also disappear. And then for this part, you substitute 4 into the b, into the 1 plus 2x. Therefore, you get 9b for the right hand side. So very easily, you will get the value for b, which is negative 1. Okay, so now I will focus on the other bracket here, 1 plus 2x. So I need to substitute a value so that this bracket itself becomes 0. Therefore, if I want to make this bracket become 0, I have to substitute x equals to negative 1 over 2. Okay, when I substitute x equals to negative 1 over 2 into the whole equation, the left hand side, I will get 18. And if I substitute the x equals to negative 1 over 2 into here, I will get 9 over 2, 8. And when I try to simplify it, my value for a will be equals to 4. Okay, so again, very easily, you will have the partial fraction like this, which is equals to 4 divided by 1 plus 2x, then minus 1 over 4 minus x. Right, so this is what we have for our partial fraction. Okay, for part A. Right, then now for part number B. Okay, for part number B, this is the question. Alright, so I hope that you can see it. Okay, so hence, find the integration, okay, giving your answer in the form of ln a over b, okay, where a and b are integers. Right, so maybe I will solve it here. Okay, since I already know that my partial fraction can be expressed, my fx can be expressed into these partial fractions. Right, so and the word hence. So hence tells you that if you want, it will be better if you can use this partial fraction to in applying the integration. Okay, so I'm having 1, 2, therefore divided by 1 plus 2x, then minus 1 over 4 minus x. Okay, so for the integration part, 4 is a constant, so I will just copy it. And then when I integrate 1 over 2x, I'm having ln 1 plus 2x. Then you need to differentiate the 1 plus 2x here, which is divided by 2. You get a 2, right? So you have to divide it by 2. Okay, and then for this part, I will have negative 1. I copy the 1. So when you want to integrate 4 minus x, I'll get 4 minus x. And also differentiate the 4 minus x, you get negative 1. Therefore, you have to divide negative 1. Okay, in your solution or in your steps. So you put in the limit. Okay, so usually for me, I would prefer to simplify everything first before I substitute the value. Okay, so for the first term, after I simplify the term, I will get 2 ln, then 1 plus 2x. And for this part, I will have plus ln 4 minus x. 2 and 1. So first, I substitute the value 2 into both terms here. When I substitute 2 into the both term, I will have 2 ln 5 plus ln 2. Then minus, now I will substitute 1 into both terms here. So when I substitute 1 into the both term, I'm having 2 ln 3. Okay, then plus ln 3. Okay, right. And from here, I will need to try and simplify it. Okay, so I have a look. Let us have a look for the final answer that you require again. So they want us to have our final answer in terms of like this in this pattern ln a over b. So that means they want to have the answer in single logarithmic function, single ln function. Therefore, if I want to put everything in a single ln or log function, generally I need to move all the number in front that become power before I can combine all the ln, right? Okay, so for this part, I'm having ln 25 plus ln 2 minus 3 ln 3. So again, the 3 ln 3 here, I will move the 3 back into the as a power, all right? And therefore, I will have ln 27. Okay, so when you are having everything without a value in front of the ln, then you can combine all of them together. So if let's say your term is with plus in front of the ln, then it is multiplied. That means it should be the numerator of the fraction. And if you're having the negative value, that should be the denominator. Okay, then you further simplify it, you are having 50 over 27. So you this is the final answer. This should be the final answer, as they want you to express your answer in terms of ln A over B. Okay, so we come to question number 5. Right, so very first they want us to expand the tangent 2 theta plus 2 theta. And after that, they want us to show that this particular equation can be expressed as a quadratic form equation in tangent power 4. Okay, so first of all, you need to know that the tangent 2 theta plus 2 theta, actually we are going to replace it in tangent 4 theta, because 2 theta plus 2 theta is equals to 4 theta. Okay, so what is the formula that we can use? We can use the double angle formula. So this is the double angle formula provided in the formula booklet. And originally we are having 4 theta, right? So you can actually try to modify this formula a little bit, okay, that you can actually modify all the angles here. So if let's say I'm having tangent 4 theta, okay, so according to the formula here, we are having 2 tangent. You can see that 2a will become 8. So that means when I'm having 4 theta, it will become 2 theta, and divided by 1 minus tangent square 2 theta. Okay, so you're having a here, right? So the 2a also become a. So you can see that the pattern of the formula actually didn't change, but we can actually change the angle for this double angle formula. Right, so tangent 2 theta plus 2 theta is actually tangent 4 theta. So for me, I will apply the double angle formula straight away. To me, which is easier. All right. Okay, so once you know how to apply this already, then we can continue. Okay, so first of all, we are having tangent 4 theta equals to half tangent theta. And since I already know that tangent 4 theta can be expressed like this, so I will just put it as 2 tangent 2 theta divided by 1 minus tangent square 2 theta equals to half tangent theta. Okay, so let us observe the answer again. So you can see that the final answer that they want us to express here, generally, right, we are also having everything in tangent theta only. So that means in my steps here, I'm still having tangent 2 theta, tangent square 2 theta. I need to expand it further to get everything in tangent theta. Right, so before I expand it, maybe I would like to move my denominator to the other side, so that it become multiply with 1 minus tangent square 2 theta. Okay, so now the next step is I will need to change the 2 theta become theta. So I'm going to apply this formula now for the double angle formula. 2, I will just copy as a 2. Tangent 2 theta, I'll write as 2 tangent theta divided by 1 minus tangent square theta. Okay, the same thing happened for the right hand side. I will have 1 minus, okay, so again tangent 2 theta I'll write as 2 tangent theta divided by 1 minus tangent square theta, and I need to square it because I'm having the tangent to theta square, right? So I have to square the whole bracket. And now I can start to simplify it slowly. Okay, so when I try to simplify so slowly, okay, first of all, you can see that I'm having tangent theta here and also the tangent theta here where I can simplify them straight away. Okay, so that's the first thing. So on top of my equation here, I will move the 2 over on top. Therefore, I'm having 2 multiplied with 2 multiplied with this 2, I'm having 8. Then divided by 1 minus tangent square theta. Then on the left hand side, I try to expand. Then I will have 4 tangent square theta and divided by 1 minus tangent square theta, and I square this bracket at the bottom. Okay. Alright, then let's continue. Okay, I want to make all the denominator disappear. Therefore, I will multiply the whole equation with 1 minus tangent square theta squared. When I multiply it, for the 8, I have 1 minus tangent square theta. Right, because originally they are square, correct or not? Then I simplify with the denominator here. Therefore, the numerator only left 1 minus tangent square theta. The term 1, I need to multiply with this whole thing. Therefore, I'm having 1 minus tangent square theta square. Then minus 4 tangent square theta. Right, so now I feel more comfortable with the equation without the denominator. Okay, so I simplify it further. Okay, so I need to expand this bracket, and I'm having 1 plus tangent power 4 theta minus 2 tangent square theta. Okay, then minus 4 tangent square theta. And if you try to compare and everything, you can see that all my terms are in tangent theta already, either tangent square theta or tangent power 4 theta. So I try to rephrase everything. Maybe I can say that I move everything to the right hand side. I'm having tangent power 4 theta, okay, minus 2 minus 4 and plus 8. So minus 2 minus 4 plus 8, I'm having plus 2, right? So plus 2 tangent square theta, then 1 minus 8, you get negative 7. So it is equals to 0. And from here, you can see that this is actually the equation that they want us to show. Alright, so let's continue to part number 2. So part number 2, you can see that they are telling us about hence. Hence, solve the equation for this range. Alright, so usually when you see the word hence, that means that they are actually telling you that it will be best if you can solve the equation from where you stopped just now or what you proved just now. Alright, okay, so this is what I have from part number A. Okay, generally, this is a quadratic form equation. So if let's say you cannot see that this is a quadratic form equation, you can let y equals to tangent square theta, and therefore you can see that the equation become y squared plus 2y minus 7 equals to 0. So very obvious this is a quadratic equation. Okay, so if you cannot see clearly, then you can solve it in terms of y, then you change it back, become the tangent theta later. Okay, so for me, I will solve it in terms of tangent theta. All right. Okay, so this is a quadratic form equation, and I realized that if I want to factorize it, I cannot factorize. So I will use the formula, which is negative b plus minus square root b squared minus 4ac, then divided by 2a. Alright, so end up I'm having two answers for tangent square theta. The first one will be negative 1 plus 2 square root 2 another one will be tangent square theta equals to -1 minus 2 square root 2. Okay, so you can get these two answers here. For the next step, I need to take square root. All right, so I have to include the plus and minus sign. And for this one, I will ignore because for this value itself, it is a negative value. Therefore, I am not able to take the square root here. Right, so I will continue from this part. Okay, so I won't get any answer from this part because you will get a math error when you want to take square root. Right, so I continue from here. So the plus and minus sign actually tells you that now I need to consider the tangent theta from all the different quadrants, from quadrant number 1 until quadrant number 4. Okay. So first of all, I will want to get a basic angle also. Alright, so the basic angle means that I'm going to change this into a positive value. If let's say I get a negative, I'll change it to become positive value, then I take tangent inverse. So when I take tangent inverse, the value that I get for basic angle will be 53.5. Okay, and then now I want to get an answer for theta. So to get the answer for theta, they are asking for the theta between 0 until 180. So which means you want the answer for first and second quadrant. Okay, so for the theta, answer from the first quadrant will be 53.5, and the answer from the second quadrant is 126.5. So how are we going to take the answer, get the answer for the second quadrant? It is actually 180 minus the basic angle, and therefore you get this as your answer. Okay, so we come to question number 6. Part number A, they want you to sketch a suitable pair of graphs. So here you can see very clearly that they want you to sketch two graphs, okay, a pair of graphs. Show that the equation for this one has exactly one root in this interval. Okay, so first of all, to sketch the pair of graphs, there are two graphs that you need to sketch here. The first one is you can sketch y equals to cotangent half x, and the other one is y equals to 1 plus e negative x. Okay, so we will start from y cotangent half x first. All right, so this graph generally start from the tangent graph. So for tangent graph, originally it looks something like this, and the asymptote here will be pi over 2 and also pi over 2 negative. Okay, so this is y equals to tangent x. And after that, when I want to sketch y equals to cotangent x, so cotangent x is actually 1 over tangent x. Therefore, the graph will become reciprocal for each other, which means that when you're having the point at 0, right, then generally you have infinity. And when you are having infinity at the asymptote part, then it will become a 0. So generally you can see that the graph will look something like this for the reciprocal cotangent for the reciprocal of tangent graph, which is the cotangent. All right. Okay, so again, I will have my graph something like this. It will touch the 0 at pi over 2, and this is negative pi over 2, and therefore the 0 here will become negative, and the graph will look something like this. So for this part, it is actually y equals to cotangent x. Alright, okay, then now I want to sketch further, become y equals to cotangent half x. Alright, so for y equals to cotangent half x, and according to the question itself, they actually want us to sketch from 0 until pi. Okay, so my original graph will look something like this. This is y equals to cotangent x that I draw on top right above just now. Okay, and since we are having cotangent half x now, therefore, for the original value of pi over 2, you need to divide it by using half. So which means that original value for x is pi over 2, and you divide it by half, and therefore the new value for this asymptote I shouldn't say yes, asymptote, it should be the line, okay, equals 0 is pi, and this will be negative pi. All right, and because of the question itself want us to sketch the graph for 0 until pi only, so that means the green color part here is the graph that I want to consider for this y equals to cotangent half x. All right, then now we go further for this another part here. Okay, so for y equals to 1 plus e negative x, the first original graph that I want to sketch is actually e negative x. So when the original pattern for e negative x is actually something like this, the asymptote is actually the x-axis. All right, and then it will pass through the y-intercept, which is always equals to 1. So this is original graph for y equals to e negative x. And if I want to sketch y equals to 1 plus e negative x, that means you need to translate the graph 1 unit up. So 1 unit up means that the original asymptote for x-axis will become the line y equals to 1. This is the line y equals to 1. And the graph and the shape is still exactly the same. It didn't change at all, just that the y-intercept will become a 2. Right? So this is actually my graph for y equals to 1 plus e negative x. So I want to combine these two graphs together in the same axis. So eventually my graph will look something like this. Okay, so I assume that this is the line for pi. Therefore, my tangent graph, my cotangent half x graph will look something like this. Okay. Okay, so what I can do here is I label it as y equals to cotangent half x. Okay, then now I want to sketch the y equals to 1 plus e negative x. So I assume this line itself, the line now is y equals to 1, and my e will start from here, which is a 2, and then we'll go down. Okay, so this purple color graph will be y equals to 1 plus e negative x. Alright, so this is how we sketch the pair of graph here. Okay, originally I'm showing you the step-by-step guide. Okay, or if you don't like the step-by-step guide, then you can straight away try to memorize the graph if you can. Right? Okay, then now what they want us to show is they want us to show we have exactly one root in this interval. So how to show that we have only one root? So when they ask for one root, we are looking for the intersection point between these two graphs. So we have only one intersection point, and therefore there's only one root in this interval. Okay, so you can mention that one intersection point can be seen, and therefore there's only one root, okay, in the interval 0 until pi. So this is how we sketch the graph and also how we make the conclusion. So we are looking for the number of intersection points. Okay, so we solve part 1 here. Let's continue to part number 2, part number B. Okay, so for part number B, they want us to verify by calculation that this root lies between 1 to 1.5. Okay, so again, to prove this, you have to look at the original equation here. This is the original equation. Okay, so to prove that the roots lie between these two values, generally for me, I will make it as a function from this original equation. So how to make it as a function? So I will move all the terms to one side. So you can have something like this. Minus cotangent half x. Right? Then I will substitute the value 1. And also I will substitute the value 1.5 into this function. And what is the value that I will get? So when I substitute 1, the value that I get will be negative 0.463. And For 1.5, I'll get 0.150. Okay, so please take note that because of the trigo function or trigo terms is involved in our calculation here, therefore when you want to get all this value, when you press the calculator, please make sure that you put your calculator in the radian mode. Alright, so all the value for 1 and 1.5 here actually refer to radian. Okay, so if you didn't do any cast mistake, you should be able to get this answer. All right, and the answer that you get should be one positive and one negative. They should be in two different signs, one positive sign and one negative sign value. Right. Okay, so once you can get these two values, then you can make a conclusion here. So you can say that there's a sign change can be seen between F1 and 1.5. Hence, you can tell them that there's a root lies between these two values. Right, so this is what they actually want us to show. Okay, so you have to show that there's a sign change when you substitute these two values. All right, so this is the steps. Okay, then now we continue to part number 3. Okay, once we locate where's the root already, roughly where's the root, then now we want to get the exact value for the final answer for the root. Okay, so here they said use the iteration formula for this one, okay, to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay, right, so our iteration formula is this. They give you this already. Okay, then now what we should do is like we have to decide the initial value. Okay, so for this question, they actually didn't tell us what is the initial value. All right, so you can choose any value that you like, and preferable it should be between 1 and 1.5. Okay, so you can use the value 1, you can use the value 1.5, or you can choose a value which is closer to the roots. So how I know that the value is closer to the root? You look at the value here. For 0.150 and 0.463, which value are closer to 0? So very obvious, 0.150 is closer to 0, right? So you can choose any value, or you can choose 1.5 as your initial value. So for me, I want my iteration to be even more shorter. Then I put my initial value as 1.4. Okay, so it is not wrong if you put 1.5 or 1, it doesn't matter. If you put 1, then maybe your iteration later will be longer, slightly longer only. Okay, right, so the initial value I decide will be 1.4. Okay, so how to get the x2? So to get the x2, that means you have to substitute the 1.4 into the iteration formula. So it looks something like this: 2 tangent inverse 1 over 1 plus e negative 1.4. Okay, then you should press the calculator and try to get the answer for this. Okay, so you have to insert the equation first before you want to calculate the value. So it should be, first of all, you have to make sure that it is in the radian mode. All right, then secondly, you should key in the formula first, which is 2 tangent inverse. Then I'm having 1 divided by 1 plus e. So to get an e, it should be e, then negative x. All right. Okay, so generally this is my formula, the iteration formula. Okay, so to key in the first value, you press on calculate. And then the first value that I want to key in now is 1.4. And I press equal sign. Okay, so after I press the equal sign, I get the value 1.3521, 4 decimal places. So I'll write it here, 1.3521. So that's my second value for the x. All right, then now I want to continue the iteration until I get the repeated value for 2 decimal places. Okay, so let me continue again. So to get x3, you need to press calculate again at the calculator part. Then you key in the 4 iteration formula just now, 1.3521. So I key in 1.3521. Then I press the equal sign again. So this is my next value, x3. So 1.3427. So at this part, I will write out 1.3427. Okay, then I continue again for x4. Repeat the same process. Press the calculate button. Then you key in the value 1.3427. Then you press equal sign. Okay, so the next value will be 1.3408. Okay, so here I will put in 1.3408. So now, after you get a few iterations already, then you can double check and see. Your final answer should be in 2 decimal places. Okay, so you try to answer for 2 decimal places here. So for this one, it is 1.35 for 2 decimal places. This one is 1.34, and this one is also 1.34. So you can see that these two values in 2 decimal places, they are actually repeated already now. So you can tell them that the 1.34 is the answer actually. Okay, so usually for me, I will continue, okay, with one more extra iterations to make sure that this is the correct root. Okay, so I will continue with one extra iteration. I will put the calculation here, and I will key in 1.3408. That equals sign. Then the next value I get is 1.3405. Right, okay, 1.3405. So again, you double check the answer for 2 decimal places again, then you realize that, okay, confirm already, the value is still the same, therefore the root will be 1.34. So this is how we actually get the root in 2 decimal places. And please make sure that you give all the value for the iteration in 4 decimal places. Okay, so we come to question number 7. Okay, so they give you a diagram here, and then they are telling you that the normal to the curve at point P with the coordinates x, y meets the x-axis at n. So you should know that for P here, generally this coordinate will be x, y. And this line is actually the normal of the curve at P. So this is the information that I can get from this sentence. Then the normal meet at the x-axis at n. So as mentioned here, this is the n. So the point n is the root, the foot of the perpendicular from P to the x-axis. So you should know that this is a 90 degrees for the n. Okay, so the curve is such that for all values of x in the interval from 0 until pi over 2, the area of triangle PMS is equals to tangent x. Okay, so they give you some extra information here, which is about the area of triangle PMN is equals to tangent x. So first of all, they want you to show that mn over y equals to dy over dx. Okay, so maybe for us, we need to try to figure out what is the relationship between the dy dx with the y and also the mn. Okay, so first of all, maybe we should look at the very first information that they give us. Alright, so you know that P is xy. Therefore, for this m here, the coordinate for m should be x and 0. And for this value n, the point n, x value I don't know, so it should be x1. Then the value of y is also a 0. Okay, and now I want to try to combine, okay, all this information related to dy dx. Okay, so first of all, maybe I try to figure out first the gradient of Pn. So the gradient of Pn means this line. So how should I get the gradient of Pn? So by referring to the coordinate of P and also the coordinate for n, so I will want to write out the formula. So the gradient of Pn is actually y minus 0 divided by x minus x1. Okay, or you can do it the other way around. Alright, so if you don't want that, you can use also the other way around, which is 0 minus y divided by x1 minus x. So this is the first gradient equation that I get for Pm. And also the second thing is I can try to link the gradient of Pn, okay, which is also equals to the gradient of normal, right? Okay, and then why I want to try to refer it, okay, or what want to compare it with the gradient of normal, it is because of from the answer given here, they try to link everything with dy dx. So I will want to link the gradient of Pn also with the dy dx. So how to get the gradient of normal? So gradient of normal is negative 1 over dy over dx. Okay, so how I know this? It is because of dy dx is actually the gradient of tangent, right? Okay, and also the gradient of tangent multiplied with gradient of normal should be equals to -1. So from this relationship, we actually know that the gradient of normal should be equals to -1 over dy dx. So this is the second equation that I can get for the gradient of Pn. So I want to compare these two equations together, all right, so that everything can be made in terms of y and also x. So I'm having 0 minus y divided by x1 minus x, which is equals to -1 over dy dx. Okay, so if I have a look for what I have here, they didn't have anything related to x1, but they try to put it in mm. So to get the mn in the answer, generally it is actually the x1 minus x. Correct or not? So x1 minus x is actually the length of mn. Therefore, I can rewrite my equation again, which is -y divided by mn. It is equals to -1 divided by dy over dx. Okay, so from this part, I think the answer is quite clear already. You can cancel off the negative for the both sides, and after that you try to cross multiply to get mn over y. It will be equals to dy over dx over 1, and this is how we get the first equation, okay, that they want us to show. All right, so generally to get this equation, what we need to do is like we have to try to link the gradient of Pn with the coordinate by using the formula, and also the gradient of Pn that is related to dy dx. Alright, okay, so this is how we actually get the equation for the first part. Alright, then now we want to continue to the part number 2. So for part number 2, it is still about the proving part. Okay, so they want you, again, you can see the word hence. Alright, so hence show that x and y satisfy this differential equation. Okay, so now you already used the very first information given in the paragraph. Then now to prove this second relation or second equation, you should try to link it with the second information given in the question. So for this second information, they are telling you that the area of triangle PMN is equals to tangent x. So maybe I can write it out first. So the area of triangle PMN is equals to tangent x. So this is a very useful information for us to start with. Okay, so how to get the triangle PMN? This is your PMN. Okay, so to get a triangle PMN, you will be half of the base. So the base means MN, right? So the MN multiply with the height. So the height means this one. So the height here will be the y. Alright, okay, so I'm having the y here, and it is equals to tangent x. Okay, refer to the answer again. So the answer is everything in terms of y, dy, dx, and x, which means that I have to substitute mn with some other thing else. Okay, so how to substitute mn into some other thing else? So again, from first part just now, you already proved that mn equals to this, right? So I want to replace this equation, the mn here, into my second part. So I'm having half the mn will become y dy dx multiplied with y equals to tangent x. So if you further simplify it, I think the answer is very obvious. So you will get half y squared dy dx equals to tangent x. And we successfully show how to get the equation that they want us to show. Okay, so this is what we have for part number 2. Right, then let's continue to part number 3, which is part B. Okay, so for part B, now they give you the initial value y equals to 1 when x equals to 0. They want you to solve the differential equation to find the equation of the curve and expressing y in terms of x. Okay, so this is a differential equation question. So where should we start? We should start from the equation in part number B. Okay, so this is the equation that we have, the differential equation that we have for part number B, part number 2, sorry. Okay, first step, you have to separate all the x variable, x and also the variable 1 to y to different sides. So for me, usually I will keep the y on the left, all the constant and also the x on the right. Then I put the integration sign. So this is the first step. You have to separate all the variable y and variable x to different sides first. Then only you can start with the integration. So to start to integrate y power 2, you'll get y power 3 divided by 3 equals to 2. So now we want to integrate tangent x. So tangent x can be written as sine x divided by cos x. Okay, so maybe for now, I will want to try to let fx equals to cos x. So when you want to differentiate cos x, you will have negative sine x. If you see the numerator on top, you're having sine x, you want to change it become negative, right? Okay, then you can use the integration technique of ln cos x. Okay, so now after I figure out the correct formula and everything already, so I will try to change the sine x become negative sine x. If I want to have the negative here, that means also I have to multiply a negative also so that they balance. Okay, they are still the same equation as what we have in the previous step. Okay, and now for the fraction inside this part, it is already the f prime x over fx. So when you want to integrate this, you have negative 2, then ln cos x, then plus c. Okay, right, then of course you need to use the initial value given in the question to get the value of c. When x equals to 0, y equals to 1. Your equation will become 1 over 3 equals to negative 2 ln 1 plus c. So this also gives you the value of c, which is equals to 1 over 3. Because ln 1 is a 0, right? Okay, so you get c equals to negative 1 over 3. Once you get the value of the constant, so you rewrite your equation of the curve again. Okay, so look at the instruction of the question. They want you to express y in terms of x. So I need to move everything, all the numbers and everything, okay, on the left to right hand side. So I'm having 1 minus 6 ln cos x. I move the 1 over 3 in front, then multiply with 3, which it becomes a 1. Then I want to take a cube root, okay, on the right hand side, and it will become 1 minus 6 ln cos x. And this is the equation of the curve that I have, and I write it in y in terms of x. Okay, so let us have a look for question number 8. They give us a diagram, and this diagram is actually the curve y equals to ln x over x power 4, and the maximum point is at m. Okay, so first they want you to find the exact coordinates of m. Alright, so first question here, the keyword will be the maximum point. And since you know that, you need to know that when we see the word maximum point or maybe any stationary point, then you have to find the dy dx, then you let it equals to 0, then you can get the coordinate of the stationary points, right? Okay, so I need to find out the differentiation for y equals to ln x over x power 4. Okay, so to find the dy dx, because this is one fraction, right? So what I'm going to do now is I have to apply the quotient rule. So for the quotient rule here, this is the v and this is u. The formula will be v squared. So v squared will be x power 4 squared. Okay, copy the v, differentiate the u, which is 1 over x, then minus, copy the u, and you differentiate the v, which is 4x power 3. Right, so you have to do a simple revision on the quotient rules, right? Okay, so to find the maximum point for m, you need to let the dy dx equals to 0. So for this step, I try to simplify this, and after that, I factorize. So after I simplify and factorize this numerator, I will get x power 3, and then 1 minus 4 ln x divided by x power 8. Okay, so I want to get the solution for all the x here, right? So I will let the numerator x power 3 equals to 0, and also 1 minus 4 ln x equals to 0. Okay, I want to get the value for x. Okay, I will refer back to the question again. So first of all, look at the keyword of the question here. They want you to find out the exact coordinates of m. So the exact coordinate means that you have to keep your answer in terms of e, or maybe in terms of pi or surd form. Right, and if we have a look for the diagram, you can see that the curve generally will not touch the diagram. All right, will not touch the diagram as what we can see here. Therefore, when you want to solve for x power 3 equals to 0, you can ignore it. All right, because you won't see any solution at x equals to 0. So we can suspect that the m here actually is solving by using this equation. Okay, so to solve this equation, what am I having here is I will bring the ln x over, and I will have 1 over 4. Therefore, the x will be equals to e power 1 over 4. So this is a coordinate, x coordinate for the m. And after that, I want to get the y coordinate for the m. Therefore, I substitute this value, x, into the y equation. So I'm having e power 1 over 4 divided by e power 1 over 4 power 4. Okay, so on top you're having 1 over 4. The denominator you are having e power 4. Oh, sorry, e power 1. Right, so if you rephrase it, then what do you get here is 1 over 4 e power negative 1, or you can keep it as 1 over 4 e power 1. Right, so from here, very easily, you can get the coordinate of m. So the coordinate for m is actually e power 1 over 4, and also 1 over 4 e power 1. So this is the exact coordinate for the point m. Alright, then now we proceed to part number B. Okay, so for part number B, okay, they are asking us to use the integration by part to show that for all the value of a greater than 1, that this equation, okay, the integration of this expression will be smaller than 1 over 9. Okay, so for this part, it is something not related to the part 1, part A. Okay, so here they already tell you that they want you to use integration by parts, okay, to show that the integration of this will be smaller than 9. So we have to solve the integration first, and the integration part here. Right, so Generally, for this ln x over x power 4, you can see very clearly that it actually consists of the product of two different functions. The first one, you can rewrite it as ln x multiply with 1 over x power 4. So it is actually the product of two different types of functions here. Therefore, when you want to apply the integration by part, you need to choose which is the expression or the function that you want to let it become u. And generally, this is a guideline, so we are using the Layard rule. Okay, ln x here, for the ln x in our expression, ln x belongs to L. This is ln x, logarithmic function. So this is L. Okay, and then for 1 over x power 4, it is A, algebraic. Right, therefore, the higher order will be the u, the lower one will be the dv. dv, yeah. Okay, right. So this is how we actually choose which one is the u and which one is the dv. Okay, so I need to cancel this off. Okay, so I already know that the u here will be, okay, so for part B, I will let u equals to ln x, and after that, the integrate of dv is equals to the integration of 1 over x power 4 dx. Okay, so for these two parts, you need to do is you need to do the differentiation for u. So you're having du dx, which is equals to 1 over x. You need to integrate this. So to integrate this, you're having v, which is equals to negative 1 over 3x power 3. Alright, so this is the steps. One part you are going to do, you are going to continue with differentiation. This part you have to get the integration. And after that, once you get all the answer, all this part, okay, then you need to continue with the formula for integration by part. So this is my original expression or question. Okay, so if I want to apply integration by part, the formula will be uv minus v du, right? uv minus v du. Or if I want to make it clearer, it should be u dv equals to uv minus v du. And this is the question. Okay, so my answer here should be uv. So what is the u? So to get the u, very obvious, it is ln x. So I'm having ln x, right? Then multiply with what? Multiply with v. So v is negative 1 over 3x power 3. And of course, you need to put in the limit of the integration, which is a to 1. Okay, then minus, right? So minus, integrate, you just write out the integration sign, v du. So from here, my v is this one, which is negative 1 over 3x power 3 multiply with du. So du, you get it from here. Okay, so to get the du, if you want to keep the du, that means the dx, you bring it up, and therefore you are having 1 over x dx. Okay, so this is we try to substitute everything into according to the formula. Right, then now we have to be very careful, okay, when you want to substitute all the value. So usually I will try to rephrase everything in a better way, okay, in a more simple way before I want to substitute any value, or before I want to continue with my integration. Okay, so for this one, I'm having 1 over 3, which is a constant. I prefer to take it out. And then I'm having 1 over x power 4 here. Okay, so next step. I will substitute the value a and also the 1 into the equation. And now I'm having negative ln a divided by 3, a power 3 minus 0. It is because of when you substitute 1 into the ln x, then you will get a 0 here. Okay, then for this integration part, the 1 over 3 is a constant, therefore I just copy it. And then when I integrate 1 over x power 4, I will get x power negative 3 divided by negative 3. And again, you need to substitute the value of a and 1 later. Okay, so continue. Just copy the first term here. Okay, again, I will prefer to take out the negative 3 from the constant. It will become negative 1 over 9. Substitute the value a. I'm having 1 over a power 3 minus, substitute the value 1, you will get a 1. Okay, and now we are almost, we already complete our integration, but you need to remember that they actually want us to rephrase and prove that our answer should be smaller than 1 over 9 for a greater than 1. Okay, so maybe we need to rephrase it a little bit more. All right, so I will try to see how can we factorize it out and rephrase it in a better way. So maybe for this one, if I multiply the negative 1 over 9 inside, I will get this. And then I'm having plus 1 over 9. Okay, and after that, I can rephrase it again. It will become 1 over 9. Then I will take out 1 over 9a power 3. And then I will have 1 minus 3, 1 plus 3 ln a. Okay, so I hope that you can see this. All right, these two terms, I factorize it, become this. Okay, so the 1 over 9, I put it in front. Okay, so usually I will try to, because the question wants us to prove that our expression is smaller than 1 over 9. So if possible, I will usually try to rephrase my answer something related to 1 over 9. So you can see here, I have 1 over 9 in front. Okay, then now it's time for us to prove in what way I can say in what way I can prove that this expression is actually smaller than 1 over 9. Okay, and what you need to know here is, since a is greater than 1, this is given in the question, right? Since a is greater than 1, therefore this part is positive because a greater than 1, so 1 over 9 a power 3 is always positive. And then for this value ln a, when a is greater than 1, ln a is also always positive. Okay, all right, and after that, when we are having 1 over 9 minus any positive value, okay, 1 over 9 minus any positive value, okay, it is the answer that you get is always less than 1 over 9, right or not? Okay, because you are having a positive value, so 1 over 9 minus any positive value, the answer that you get is always less than 1 over 9, and therefore you can make a conclusion here, 1 over 9 minus 1 over 9 a power 3. So the answer for our integration is always smaller than 1 over 9 for the value a greater than 1. So this is how we actually prove it out. Maybe you just need to write a simple sentence, right, how you clarify it or justify it. All right, so this is how we solve the question number 8. Question number 9. Okay, so we have a quadrilateral ABCD is a trapezium, and then they are telling us that AB and DC are parallel. So with respect to the origin O, they give you all the position vector for A, B, and C. And part A, given that DC equals to 3AB, and they want you to find the position vector of D. Okay, so I think this is not a very complicated question, right? Okay, so we will start from the information given by the question itself. So DC is equals to 3AB. So by applying some simple operation, then you should be able to get the position vector of D lah. So for your information, position vector of D will be OD, right? Okay, so the symbol will be OD. Okay, so DC, I can rewrite it as DO plus OC, where DO, I don't know what is it, right? And then plus OC. For OC, it is given in the question, which is 2, 2, and negative 3 equals to 3AB. So the AB, A means AO. AO will be 1, negative 2, and negative 3 plus OB. So OB will be 1, 3, and 1. All right. So generally, this is how we start. Now, we will use the information given by the question, and then we will substitute all the position vector that we know and try to get the OD. Okay, so since we are having DO here, therefore, I can rewrite it as negative OD. So DO is negative OD plus 2 to negative 3, and it is equals to 6, 3, and negative 6. So for this part, you need to do some simple mathematical operation so that when you multiply the 3 and everything in, you can get this as the answer. Okay, so hope that you can get this as the answer. All right, then if you continue further, and if you didn't do any careless mistake, the OD answer should be negative 4, negative 1, and also the 3. Or you can rewrite it as negative 4i minus j plus 3k. So this is actually the position vector of OD, of D lah. All right, so or we call it as OD. Okay, so to me this is quite straightforward lah, this question. All right, so it should not be a very big problem for us to solve it. Okay, then now we can continue to part number B. Okay, they want you to state the vector position for the line through A and B. All right, so maybe we can put it here. Okay, so what is the position, the vector equation for the line through A and B? Okay, so that means you're having point A and also point B, and what is the position vector for this line, the vector equation for this line? Okay, so generally the equation, the formula will be R equals to A plus TP, where A is the passing point of the line and then P is the direction of the line. Okay, so very obvious. When the line pass through A and B, right, you can use either OA or OB lah, up to you. Right, so what is the OA here? OA will be negative 1, 2, and also 3. So you can write out as negative 1, 2, and 3. Or if you want to use 1, 3, 1 also can, which is the B, also no problem, plus T. What is the direction of this line? So the direction of this line is actually the AB. This is AB, right? Okay, and you can simplify it to the, this is 3AB. So you can simplify it to the most simplified answer, okay, where it should be 2, 1, and negative 2. Okay, so next we come to the part C. For part C, they want us to find the distance, okay, between the parallel sides. And after that, they want us to find the area of the trapezium. So maybe first of all, we need to know roughly how our trapezium look like. Okay, so we are having ABCD, right? Okay, so trapezium generally will look something like this. Okay, so maybe I can label this as A, B, C, and D. And AB and DC are parallel. Okay, and then to me, I think this is quite true because DC equals to 3AB, so AB should be shorter, right? Okay, then now they want you to find the distance between the parallel sides. So the distance between the parallel sides should be this one, D, the height. Okay, and it is something like we want to find the perpendicular distance, okay, from a point to a line. Okay, and since we already have the equation of AB, the vector equation of AB in part B, right? So maybe for me to make the calculation easier, I will assume that the vector equation AB, okay, the line AB, I extend it, and then I will take C as a reference point, and the foot of perpendicular from C to the line AB is F. I will label it like this lah. So my aim is to find out the D, the distance, the height, which is also equals to the length of CF. Okay, so this is what I plan to do it in my calculation here, in my solution here. All right, okay, so C So in short, this is actually what I want to find is I want to find the perpendicular distance from the point C to the line AB. Okay, I want to find the perpendicular distance from point C to the line AB, and I treat F as the foot of perpendicular, okay, from C to AB. All right, so since F lies on the line of AB, therefore the position vector of F is also equals to the vector equation of AB, just that the value of t might be different. So you can substitute by using the s. So OF I can rewrite as 1 plus 2s, negative 1 plus 2s, then 2 plus s, 3 minus 2s. So this is my position vector of F. Second step, I want to find out the vector for CF. So CF will be CO. CO is negative 2, and 3 plus OF. So OF is negative 1 plus 2s, then 2 plus s, and also 3 minus 2s. Alright, so from here, end up your CF will be negative 3 plus 2s, and then s, and also 6 minus 2s. Okay, so after I get the CF already, the next step for me will be, since I know that CF and AB are perpendicular to each other, right? Which means CF multiply with AB, or the direction of the vector equation AB, it will be equals to 0 because they are 90 degrees to each other. So this is one of the property that we learned in vector before. Right, so CF is negative 3 plus 2s, s, and then 6 minus 2s, multiply with the AB. So AB, we already get it just now in part 1, or maybe even in part 2, which is actually 2, 1, and negative 2. Alright, and you let it equals to 0. Okay, so we apply the dot product between these two vectors. Okay, and this is what you have, and you let it equals to 0. Try to further simplify it, and eventually you should get 9s equals to 18, and therefore the s is equals to 2. Okay, so this value s equals to 2 is important because you can substitute it into CF. Alright, so when s equals to 2, the value of CF that you get now, the vector that you get now for CF should be 1, 2, and 2. Alright, then the height of trapezium is actually equals to CF, right? The modulus of CF. So you can write here, the height of trapezium is equals to the modulus of CF. Alright, so it should be square root 1 square plus 2 square plus 2 square, which is equals to 3. Okay, so I already achieved the very first request in the question where they want us to find the distance between the parallel sides. So the distance will be 3. And now we want to go and calculate the second part, which is to find out the area of the trapezium. So to find the area of the trapezium, you need a few distance. Right, so the first one is you need the distance of AB, the length of AB, the length of DC, and also the length of the height. So the length of the height we have it already. Okay, so now we need to continue to proceed with the length of AB. Okay, so for the length of AB, you already get it just now from first part also, which is 2, this is AB, right? Okay, so 2, 1, and negative 2. Therefore, when you write out, it should be 2 square plus 1 square plus negative 2 square. The value is also equals to 3. And after that, when they want to get the length for DC, from first part, you know that the length of DC is 3 times of the length of AB. So it is equals to 9. Okay, so everything you can get it from the first part and the second part. And now you want to calculate the area of trapezium. Okay, so the area of trapezium formula will be half multiply with the height of the trapezium and multiply with the addition of the parallel side. So the addition of a parallel side will be 3 plus 9. Okay, the parallel side is AB and DC, so should be 3 plus 9. And from here, after you calculate it, you should get the value 18. So area will be 18 units squared. Alright, so this is how we actually get the area of the trapezium. Okay, so we try to fulfill what the question wants us to find out. So first part of the question is they want us to get the height of the trapezium first, and after that only we get the area. So you have to show them two answers here. Alright, so this is how we actually solve the question number. Okay, so we come to the very last question for this paper. Okay, so for part A, for question number 10, they want us to verify that this is the root for the equation, this one. Okay, so which means that this is actually the z if it is a root, right? Okay, so first of all, maybe what you need to do now is we can try to find out the z square and also the z power 4 first. Okay, so what is z square? So z square means that you are having -1 plus square root 2i and then -1 plus square root 2i. Okay, right, so you expand the bracket, you're having 1 minus square root 2i minus square root 2i, then you're having plus 2i squared. So please take note that the I square here is actually -1, right? So you're having 1 minus 2, you get -1 minus 2 square root 2i. So this is what we have for z power 2. And in our equation also, we are having the term of z power 4. So we can also try to get a z power 4 in advance. So z power 4 means that z square multiply with z square. And you will get -1 minus 2 square root 2i. Same thing happened for this. Okay, all right, so again you expand the bracket here, -1 multiply with -1, you get a 1, then plus 2 square root 2i plus 2 square root 2i, and then you're having plus 4 multiply with 2 multiply with I squared. Okay, so again, if you want to simplify the I square here, it will become -1. So you're having 1 minus 8. 1 minus 8, you get a -7 plus 4 square root 2i. Okay, so I already get the z squared and z power 4. Therefore, now I want to verify that it is actually the equation for this one, the root of this one. Okay, so from the left-hand side of this equation, you're having z power 4 plus 3z squared plus 2z plus 12. And it is equals to z power 4. We already calculated just now. Okay, then plus 3 z squared. So z squared is -1 minus 2 square root 2i. Okay, then z itself is -1 plus square root 2i, then plus 12. So what you need to do now is you just try to simplify this whole expression and try to get the value 0. Right, so you expand everything. Okay, then you double check and see. So -7 minus 3 is -10 minus 2 is -12 plus 12 it is equals to 0. Okay, then you are having also 4 square root 2i minus 6 square root 2i plus 2. So again, you can see that it is equals to 0. So which means that the -1 plus square root 2i is a root of this equation. Okay. Alright, so this is how we prove for part A. Okay, then now we continue to part number B. Okay, for part number B, they want you to find the other roots of this equation. Okay, so for this equation, it is in terms of z power 4, right? You're having the highest power of 4, which is z power 4. So we should assume that we might have up to 4 roots. Okay, Right, so now if you double check the coefficient of every single term here, in front of z power 4 is a 1, in front of z power 2 is a 3, in front of z is a 2 and 12. So all these coefficients here are real number. So when you're having a real number in the polynomial, okay, you should know that the roots come in conjugate pairs. So that means one of our root in part 1, part A is this one, -1 plus square root 2i. So automatically we know that all the coefficients are constant, or sorry, are real number. Therefore, we should know automatically that the other root come in conjugate pair, which is -1 minus square root 2i. Okay, so from here you already have two roots in your hand. So that means this is root number 1, the first one. Okay, so this is root number 2, and you can see that they are appearing in conjugate pairs because of the coefficient of all the z in the polynomials here are real number. All right, then now we have two roots already. We need to find another two roots. Okay, so to find the other two roots, you need to form a quadratic factor, okay, by using these two roots here. How to form a quadratic factor? Okay, so in a more simple way, quadratic factor is you can write as x squared, or maybe in this case we should write as z. All right, so we're having z squared minus the sum of roots z plus the product of root. SOR means sum of roots. POR means the product of roots. We are having two roots in our hand, right? So the sum of roots means that -1 plus square root 2i minus 1 minus square root 2i. So you add the two roots together, multiply with z, plus the product of roots will be -1 plus square root 2i, multiply with -1 minus square root 2i. And this will form the constant term in the quadratic factor. Okay, so if you continue from here, okay, eventually you should get plus 2z. Okay, when you try to simplify, you should get plus 2z. And after that, for this one, you try to expand the bracket, you will have plus 1. Okay, then minus square root 2i plus square root 2i, then plus 2. Okay, so eventually the quadratic factor that you form, you can get is plus 3. So this is my quadratic factor. Okay, so what is the use for this quadratic factor? It is because of I want to apply the long division, okay, for this equation z to find out the quotient. So I need this quadratic factor. All right, so my polynomial is something like this, okay, in terms of z. All right, then my quadratic factor will be z squared plus 2z plus 3. Okay, right, so you should try to apply the long division now. So I'll multiply it with z squared. So I'm having z power 4. So z squared multiply with 2z, I'm having plus 2z power 3, then plus 3z squared. Okay, so negative 2z power 3 plus 0z squared plus 2z. Then I continue again. I need to multiply it with negative 2z here. So negative 2z power 3 minus 4z squared minus 6z. Okay. All right. Then again, I'm having 4z squared plus 8z plus 12. Then the next number will be plus 4. 4 plus 2, 4 multiplied with 2, you get an 8. Then 4 times 3, you get 12. And you have no remainder. So that means it can divide it nicely. Okay, completely. Okay, so how can I get the other two roots? So you should get the other two roots from this quotient. All right, so this is the quotient. from the long division and want to let this equation equals to 0. Alright, okay, so when I let z power 2 minus 2z plus 4 equals to 0, you will realize that actually we're not able to factorize it also lah. So to get the z, you need to apply the formula, the quadratic formula, which is negative b plus minus b squared minus 4ac and divided by 2a. Right? Okay, so if you try to simplify whatever you have in the bracket itself, you should have square root negative 12 divided by 2. Okay, and then for the negative 12, you can rewrite it as negative 1 multiply with 4 multiply with 3. So the negative 1 here for the square root, later it will become I. Square root 4 will become a 2. Square root 3 will remain as square root 3. Right, so if I rephrase it again, then this is what I have, plus 2 plus and minus 2 square root 3i divided by 2. And the 2, 2, and 2 here can be simplified. And therefore, your z is 1 plus minus square root 3i. So this is actually your root number 3 and also the root number 4, okay, for this polynomial. Okay, so to make the examiner mark easier, so I will list out all the roots. So what are the roots for this polynomial is negative 1 plus square root 2i, negative 1 minus square root 2i, then 1 plus square root 3i, and the last one will be 1 minus square root 3i. And again, this shows that when we are having z power 4, right, our roots might go up to 4 roots. And these are all the 4 roots that we can find. And all of them are complex numbers. Right, so we ended the discussion and solution for this paper. So hope you understand this.